Next, I will introduce character recognition network. First, we want to do an end-to-end network. The structure is like this. We input the whole plate and make it through a CNN, and we divide the last layer into seven parts. Every part will give out one character. The advantage of it is fast speed. However, since the dataset is too small, this model overfit a lot. Next, we tried segmentation. We have two different methods. The first one is fixed point, which means we cut plates at fixed place. The reason of it is the plates are from the same country and are very familiar to each other. The area occurs when the plates out. The next method is least pixel. First, we transform images to binary image, like this. We can find that the area of character has more pixels than white area. So we cut plate at where the pixel changes most. This one have more precision. However, it may cut out less than 7 characters or more than 7 characters. Next is a character recognition model. Since the number and letter we cut out has different size, so we resize them to 60 multiply 40 first, and then use two different models to practice them. Since our dataset is very small, we use a very small model like this. Next, we implemented max select method because in the dataset we have 3 different images for one car. So we can let them vote for every characters, and then 30 images will come out one result. Okay, the weight pruning method is very simple. We want to limit our weight to be -1, 1, and 0. First, we will calculate average absolute values of weights each layer. And then according to average values, we will assign the weight and do retraining, and assign the weight and do retraining. The value of them gradually reduced from 2 to 1. So at last, the weights will all be -1, 0, and 1. Results. Okay, before pruning, the memory cost of the number model is 3000 KB, and the accuracy of all right is 64%, which means we can predict all 7 characters right, and the percentage of 6 right characters is 93%. Okay, after pruning, the memory cost is 38 KB, and the percentage of all right is 57%, and the percentage of more than 6 right is 80%. Okay, let's show some prediction examples. The first one, let's give out AAD5801, and second one give out APU3892, and third one gives out AQL0951. We can find that the third character performs worse because it have a dot just near it. It will cause some error. Okay. Next, we implement FPGA acceleration. We can find that because our network is very small, so it doesn't acceleration a lot. Okay, now the model is not good enough. I think the most problem is that our dataset is too small. So in the future, we will do some improvement. like adding more data, or pre-processing images to reduce noise, or doing data augmentation. Thank you.